Here's the second set of your notes, starting with sign relationships. Very important slide on this because you need to understand if Q is going to be positive or if Q is going to be negative. So for instance, front side of the mirror, light rays are going to reflect and form a real image. If you form a real image, that means that you're going to have a positive Q in your givens, or if you solve for Q, the image distance, then it's going to be a positive value. Whereas if the image falls on the back side of the mirror, then that means that the light rays do not exist and a virtual image is formed. So that's going to be a negative Q value. So either your givens are going to have a negative Q or your value that you're going to solve for is going to have a negative Q. Furthermore, please just dismiss this P value here, guys, because it should make sense that your object distance is always going to be positive. So if you have a Q that has a positive sign, then that means that you are looking at the image going from center to front side of mirror. From center to front side of mirror. That's just reiterating what you see up top on this same slide here. So once again, that would be a positive Q. Positive Q means image will be from center to front side of mirror, whereas a negative Q would imply then that the image forms on the back side of the mirror. So just look at the challenge problems and look at the practice problems. And where am I telling you that these images are formed? There's like a lot of information that's given to you just on the wording of the problem that you'd be able to decide, oh, well, she's telling me that the image is formed on the back side of the mirror, therefore my Q has to be negative. Okay, so look for little helpful hints like that. Okay, more sign relationships. Focal length is always positive. So F, you're going to have a positive F. Why is your focal length always going to be positive? Because the mirrored surface is on the front side of the lens. Or not the lens. Because the mirrored surface is on the front side of the mirror. Once again, front side would imply positive. The object height, that's H, and the image height, H prime, are positive when both are above the principal axis. Okay, so what do I mean by the principal axis? Later on, we're going to see that here's like your mirrored surface. You're going to have an object that's placed onto there. We'll just call it an arrow for right now. Put an O through it, so it means object. You're going to go here, go back through. You're going to go back through to here, and you're going to just line it up and go through. So where those three lines intersect is where the image should be formed. So once again, the principal axis is like the equilibrium line. Okay, it's like the home base. It's the surface. So this line is your principal axis. Both will be negative then. H and H prime will be negative when below the principal axis. Okay, magnification. Magnification is denoted as a capital M, and it's going to relate image to object sizes. And if an image is smaller than the object, then that means that your M is going to be less than 1. If your image is larger, M will be greater than 1. Okay, so if M equals 1, then the image equals the object. They would be the same. So the equation that you're going to use through here, there's actually two. You're going to use m equals h prime over h, or more commonly, you're going to use m equals negative quantity q over p. This is going to be the one that you're going to use more often, negative quantity q over p. So in other words, you know that your h is talking about your object type. Your h prime is your image height. Your q is your image distance. And your p is your object distance. Now, there's no variables written on here because, once again, just as long as the variables are the same, it doesn't matter. Furthermore, the last thing I'd like to note is units for m equals none, because it's going to be h over h, so like centimeters over centimeters, or it's going to be q over p, meters over meters, or whatever. So they're going to cancel out. Therefore, magnification is going to be a number that is equal to 1, less than 1, or greater than 1. That's it. Magnification sign relationships. This is another one of those really good slides to know. If you come up with a negative m, okay, if you come up with a negative m, that means that the image is in front of mirror. Second thing is that the image is inverted. And lastly, that the image is real. Okay, so one thing I want you to notice right now is if I ever ask you about the image equals, you're always going to tell me two stipulations. You're either going to tell me real and inverted, or you're going to tell me with a positive q then, or sorry, a positive m, what we're talking about is then the opposite of what you see above. So for a negative m, the image is in front of the mirror. A positive m would mean that the image is behind the mirror. Also, instead of the image being inverted, that would mean that the image is upright. If the image is upright, then you call it a virtual image. So once again, if I would ask you to solve for the orientation of this object or the image of this object, you would have to give me two criteria. You would say that it is virtual and upright. So real quickly here, something I'd like a point that I'd like to make is that you're not going to see virtual and inverted, nor are you going to see real and upright. Okay, if you have real, you have inverted. If you have virtual, you have upright. That's the only two ways you're going to see those words interact with each other. Okay, so here's rules for drawing free body diagrams, which you are going to get worksheet in class to figure this stuff out. So don't fret over that yet, at least. Sample problem B. Concave spherical mirror has a focal length, so that would be an F, of 10.0 centimeters. Locate the image of a pencil that is placed upright. Okay, so virtual and upright is what we're trying to imply here. 30.0 centimeters from the mirror, so that's our P. 30.0 centimeters. Find the magnification of the image and draw a ray diagram to confirm your answers. So with that in mind, it's a concave mirror, so you have that positive F value. Obviously, your P needs to be positive. You're solving for Q in centimeters. You're solving for the image orientation, and you have an M. Eventually, you'll go back and see if this ray diagram makes sense. That's what we're hopefully going to be able to draw here in the next couple of days in class. So your mirror equation is 1 over P plus 1 over Q equals 1 over F. You want to rearrange that? Well, not really, because you have F. And then when we get the answer, you just want to take the inverse of it. We're trying to solve for Q. So that would be 1 over Q equals 1 over F minus 1 over P. So that would be 1 over 10.0 minus 1 over 30.0. Putting that into your calculator gives you 0.067. And then you want to take the inverse of that, because this is what 1 over Q is. So therefore, 1 divided by second answer gives you 14.925. You only want 2 sig figs, so your Q is 15 centimeters. Okay, my question to you, should it be a positive or a negative Q? Well, looking back here in the problem, it says upright. So you know, we can go ahead and answer the image question right now, that your image is virtual and upright. Okay, half of that answer was given to you right in the problem. So it's just a matter of proofing it. Well, you're proofing it right there by telling me that it's a positive Q. A positive Q does imply a virtual image. Your magnification is negative quantity Q over P. So that's going to be negative 15 divided by 30.0. Hopefully you don't need your calculator for that, because that's just negative 0.5. Well, with sig figs, that's going to give you a negative 0.50 nothingness, right? The units cancel out. And that's how you're going to solve through this problem here. Now we're going to go ahead and do the same thing here, so the answer is to B. Now we're going to go ahead and do the same thing with convex spherical mirrors. These are going to be mirrors whose reflecting surface is an outward curved segment. Outward curved segment of a sphere. Really good slide to know here as well. These do a great job showing you the sign conversions of what you should be seeing for each of the different variables. Please make sure you look over that on page 464, guys. Okay, so sample problem C. Sample problem C says that, once again, an upright pencil, so we should be seeing virtual and upright at the end, is placed in a convex spherical mirror, focal length 8.00 centimeters. The erect image, so the type of the image, H prime, 2.50 centimeters, is a P of 4.44 centimeters behind the mirror. Okay, it's formed behind the mirror, so right there tells you a virtual image. Find the position of the object. Oh, I apologize. That is your Q. That is 4.44. So it says find the position of the object. So that's going to be P in centimeters. The magnification of the image and the height of the object in centimeters, because your H prime was given to you in centimeters as well. So with that in mind, it's a convex mirror. Convex mirrors give you a negative focal length, and they also give you a negative Q. Okay? So this is going to give you 1 over P plus 1 over Q equals 1 over F, in which you want just 1 over P, so that's 1 over F minus 1 over Q, which is 1 over a negative 8.00 minus 1 over a negative 4.44. Take the inverse of this as well, guys. When you take the inverse of this as well, you get negative 10. But you know that your P should be positive values. So your P comes out to be 10.0 centimeters. Your P is going to be a positive value. With that in mind, then, you can go through and solve for your M. Your M value is a negative quantity Q over P. So your M is negative, Q was a negative 4.44, and your P was a 10.0. So that it just means a moving of the decimal. So that's 0.444. And your magnification then with your 3 sig figs is 0.444. It's a positive M. So if you look back in your notes, you see that a positive M is going to give you a virtual upright image, and it is placed behind the mirror, and that's exactly what this problem says that you were to get, so we're good to go on that portion of it. Okay, and then finally you want your H prime over H is what M is, so rearranging that, that gives you M over H, that gives you H equals H prime over M. Plugging in and solving through for this gives you 5.63 centimeters. Here are your answers for C. Okay, please make sure you look through these, and that is it for this section.